Assalamu alaikum everyone. So we'll continue with our lecture on leveling. Now we'll talk about some methods to find difference in levels. We've already discussed a few in the introduction, but let's see them again. So the first method is differential leveling. So this name is used for when we use auto level to find out level differences, and differential level is one of the subcategory. So in differential leveling, what we do is that between the 2 points whose elevation difference we want to find out, we place the instrument. It doesn't have to be between them. It can be anywhere so that the 2 points are visible, and the height of the instrument can cover the 2 points. So if this point was somewhere over here, then this setting of the instrument wouldn't allow you to view that point. So either you would have to increase the height of the instrument by changing the length of the tripod legs, or you'll have to move it somewhere else so that you can see the 2 points. So once you place it like this, like we discussed, the first reading that you take is the backside on the point whose reduced level is known. So this is called as benchmark. And in this case, a rock placed over here is actually your benchmark, whose reduced level is 820. Now, when you place leveling staff on that point and you set any height of your instrument, then when you note the reading on that leveling staff, whatever reading you get, you add in the benchmark, because the height of the instrument is always above the height of the benchmark. So when you add it in the reduced level of the benchmark, so that becomes your height of the instrument. So 820 plus 8.42. So 828.42 becomes your height of the instrument from the datum, where the reduced level is 0. And then the point whose reduced level you want to find out, which you want to make your benchmark, you place the leveling staff over there. You note down the reading. Now, the reading where the crosshairs of your instrument strike the leveling staff, that line is actually your line of collimation or line of sight, and that is the plane whose reduced level is 828.42. Now that is above the point whose reduced level you are trying to calculate. So whatever reading you get on the leveling staff, you subtract it from the height of the instrument so that you get the reduced level of that particular point. So in this case, 828.42 minus 1.20, which is the reading on the leveling staff without changing the position or height of the instrument. So you get reduced level of that point is 827.22. So this is called as differential leveling. But we have some other methods which may not be as accurate as this one, but let's discuss them. So another method is barometric leveling. So barometric leveling, we make use of the difference in air pressure. So as the altitude changes or elevation changes, the air pressure keeps on changing. And there is a relation between how much is the change in air pressure with the change in height. So we have different instruments that can actually gauge that. So these are the instruments that are also installed in aircrafts as well. Uh, but we have a better version which is called as serving altimeter, which makes use of this property of air, and based on that it gives you increase in elevation or reduced level. But obviously this is not as accurate as uh, the differential leveling process is using the auto level, but still, if you don't want that much accuracy, or if you want it to be over quickly, so you can use this. Then we have trigonometric leveling. So this basically makes use of your ability to estimate or observe angles in the vertical plane. So if this is my instrument that can measure vertical angle, which is usually a theodolite that has the capability. So when you keep the telescope completely horizontal, as we did in the case of auto level, so that line would mark the 0 degrees. And when you rotate the telescope in the vertical plane, and whatever your new point is, you can stop it over there, and the instrument will give you the vertical angle. Now using that vertical angle and the horizontal distance, we can easily find out the height in the vertical plane or elevation or reduced level using the trigonometric ratio. So in this process, you don't need a leveling staff. what you need is an instrument that can measure angles in the vertical plane, and you need a measuring tape or some other instrument that can give you horizontal distance, and then by using trigonometric ratios you can find out the elevation. So this is trigonometric level. And then we have some other methods which are relatively new. uh, First we have sonic altimeter that uses a series of high pitched sounds to gauge distance. So again, this is based on the principle of EDM that we discussed before, that it sends out a wave of known velocity, and it measures the time the wave took to rebound off the surface whose height you want to find out, and then it will give you the relative heights of different points. The similar process is used in another instrument, in radar altimeter. Nowadays, we have this very high precision instrument called LiDAR, laser detection and ranging. So it basically works on the same principle. It flies over any area whose elevation differences you want to find out. It sends out beams of uh, laser, multiple beams, and then it can give you a complete profile of the area. We call that as digital elevation model. You study that in the next semester, and that's a very quick method to find out elevation differences in a large area. So instead of using your instrument of auto level and taking a lot of random points, a lot of observations, and then performing calculations, that is replaced by these new instruments. But obviously, we don't have them everywhere, so we need to know the basic ones as well. And then we have the GPS. So GPS doesn't only give you latitudes, longitudes, it can also give you altitudes. So if you have a good one, you can also use that to find out elevation differences. But let's come back to our instrument, auto level, and let's discuss different parts of the auto level. So first you have this instrument. Beneath that, you have over here, you will have a tripod stand on which you will fix this instrument. And this has this object lens over here, and this is the eyepiece. So you view from this side, and this whole thing is called as a telescope. And the objective of this objective lens is to gather light, and from the eyepiece you can actually view an enlarged view of your leveling staff. And the magnifying power of the eyepiece is about 25 to 45x. It depends on the model of the instrument that you're using. And then we have this side view above. So what this is basically that over here you get a magnified view. So in a large perspective, in a large view, it is sometimes difficult for you to locate your leveling staff. So in order to set the direction of this whole equipment, you can first view through this sight, which doesn't magnify the image, because you just want to locate your leveling staff. You don't need to note down the reading. So you don't need magnification. So just to set out the direction of this auto level or this telescope, first you view through the sight so that your leveling staff is visible, and then you can switch to the eyepiece to get a magnified view to note down the reading. This is similar to as when you're using binoculars, and first you look through naked eye without the binoculars to set a direction of where you want to look, and then you use the binoculars for magnified view. So looking through the eyepiece is like looking through binoculars, and looking through sight is looking just with your eyes and locating the object. Then we have this circular bubble over here. So this bubble would tell you if your instrument is completely leveled or not. By completely leveled, I mean that the horizontal line or horizontal plane is tangent to the level surface, right? So that is when the circular bubble will be in center, and that would mean your instrument is leveled, and that is when you can take the reading, not before that. Over here, we have this horizontal motion screw. So if you have experienced this with your cameras as well, that when you are looking through a zoomed view, um, moving your camera slightly moves the image a lot. So the similar thing happens when you're looking through the eyepiece. By rotating it just a little, the whole image moves by a lot. So instead of moving the instrument with your hand, we use this horizontal slow motion screw. So if you rotate it, it rotates the instrument very slightly so that the image does not change too quickly, so that your leveling staff does not get out of view. So if you move it with your hand, there's a chance that it will get out of view and then you'll have to reposition yourself again. So if you want to move the image slightly, then we make use of this horizontal slow motion screw. So here's a picture of TopCon auto level, a similar model that we have in our lab as well. So over here we have the circular bubble. Over here we have the side view, the eyepiece, the objective lens, the horizontal slow motion, leveling screws, and beneath that you have the tripod. So when you want to level your instrument, first thing is to roughly level it using these tripod legs. So that is an approximation to bring your instrument roughly to a level position, and then you can use these three leveling screws with the instrument. Now when you rotate these leveling screws, the instrument moves up and down from that position of leveling screw. So by using three leveling screws, you can tilt your instrument until the bubble comes in the center and your instrument is leveled. Then this instrument is not used alone. We have discussed that you need a leveling staff with this instrument, and we have different versions of leveling staffs. Some are in feet, some are in meters. We have different patterns of graduations on these instrument on this leveling staff. So we have a number of variations. We'll discuss that in the lab. But just for a brief view, on this instrument, you can see this is just like a ruler that you use. We have these graduations on it, and over here you have one. So if it is in meters, that would mean over here we have 1 meters at the base where you place it on the surface whose reduced level you want to find out. It's 0. This is 1 meters and this is 2 meters, and that would mean that this whole of it is 10 centimeters, so that all of it is 100 centimeters, and we have a 1 meter difference from 1 and 2. Now usually when you're looking through a magnified view, you cannot look at it like this. Your view would be limited. It would be in a circle with the crosshairs and a very limited view. So that is why they write down this one in smaller font. So that is because when you're viewing it through this, if this big one or two is not visible, so you wouldn't know what part of the leveling staff you are reading, and this tells you that this is actually 1 meters. So if you're noting down this reading, you would know it is 1.63 and not 2.63. So let's look at a magnified view. So like I told you, since this 4 is written over here in a smaller font, that means whatever reading I'm going to take, it's going to be 4 point something. Now if we look between two bigger graduations, let's say 3 and 4, now this line over here means 3.0. This graduation means 3.1, 3.2, 3, 4, 5, 6, 7, 8, 9, and this would be 4. So this is how you read it. So if I am right over here, that means the reading is 4.6. If I'm right over here, that means the reading is 4.5. And if I'm over here, that means the reading would be 1, 2, 3, 4, 5. So this would be 4.55. So this is basically how you read the leveling staff depending on what type of a leveling staff you are using. And that would give you the least count of the instrument as well. Now there are some other types of leveling instruments, a dumpy level and a tilting level. These were older ones, so the difference was in telescope. So we didn't have a very modern telescope back then, so it was different looking. And also the leveling process, how to level the instrument, that process was a bit different. So we had dumpy level and tilting level, and then we have more modern instruments, the one that we use now, which is an auto level. So that has the capability to level itself very quickly using the leveling screws. And then we have digital levels, more modern ones. So the benefit of using digital levels is that most of them have a laser to note down the reading. And also it can make a profile of the land as well. It can store the values. So instead of noting them down yourself, the instrument can store it, and then they can also give you a rough map of the area as well, depending on which model you are using. And then we have leveling staffs that we discussed. So let's move on. So these are different types of leveling staffs. Some are in meters, some are in inches and feet, and a lot of them have, even in the same units of meters, they can have different ways of graduating those values on the leveling staff. So that depends on which staff you are using. So now let's come to the leveling process. So the first thing that you have to do is you have to place your leveling staff at a suitable location. Now, a suitable location is determined by which readings you want to take. If you want to take a lot of readings, then what you need to do is you need to place the instrument at such a location that makes as many points visible as possible. Because if you don't do that, that means you'll have to change the location of your instrument again and again. You'll have to level it again, and the calculations will be increased. So that is why you need to place it at such a location that maximum points are visible. So once you have decided on the location, you need to place the tripod legs firmly, place them in the ground, because you don't want the instrument to be moving once you have started the work. So if you fix the legs in the ground, that means by wind or by a slight push, the instrument won't be disturbed, the leveling won't be lost, and the whole observations that you took before won't become obsolete. So once you have done that, you will level the instrument using first the tripod legs by changing their length, and that would help you to approximately level the instrument. And then by using the leveling screws, you will perfectly level the instrument. Once that is done, you will use the eyepiece to focus on the leveling staff. So focusing is important because that eliminates the parallax, which is the blurriness in your image, or the image is not unique. You get to see two different images, so we have different sort of errors in the image, and one of them is parallax, and you can remove them by using those focusing screws. Now that was about the instrument, and now comes the other person who is holding the leveling staff at the point whose reduced level you want to find out. Now the person holding the staff needs to hold it vertically, so it shouldn't be inclined forward or backward, and it should be placed directly above the point whose reduced level you want to find out. Once that has been done, then you can note down the reading and proceed with the calculations. Now, one thing about this instrument is that you can't use it in isolation. So one person cannot do this job. You need at least two people to do it. One person on the instrument, the auto level, and one person holding the staff. In modern instruments, we have this auto level with a laser. So once you've leveled it, you have sighted the object where, or the location where you want to find out the reduced level, you turn on the laser, and then you can leave the instrument as it is, and you can go to the leveling staff, hold it yourself, and the laser would point on the leveling staff, and you can note down the reading over here. So that means you don't have to look through the enlarged view through the telescope to note down the reading. You can do it while standing with the leveling staff, noting where the laser is, and then noting down the reading. But the instrument that we have, we need two persons minimum. So the person holding the leveling staff needs to make sure that one, he holds it from the sides so that the reading is not hidden behind his fingers. Two, he needs to hold the staff vertical. That is because if the staff is inclined forward or backward, the reading would change. So what would happen if the staff is inclined forward? That means the reading on my auto level would be greater than the reading there should have been had the staff been vertical. And if the staff is inclined backwards, then again the reading would be more than the actual reading. So that means the person noting down the reading at the instrument can ask the person holding down the staff to move the leveling staff forward and backward, and he can look for the reading when the reading is minimum. So at that point, he can ask the leveling staff person to stop, and then he can note down the reading. Another thing that the leveling staff person needs to take care of is that since the instrument can open up to 5 meters, and it is made up of metal, so he needs to make sure that there are no wires above that can hit the leveling staff. So that's a safety hazard with the leveling staff as well. So these were the temporary adjustments that we were talking about. Selection of a suitable position from where you can view maximum points. Now remember, the instrument does not have to be placed between the 2 points whose reduced level you want to find out. So there is no centering in auto level. You can place your instrument anywhere. So even if the 2 points that you want to measure are here and here, you can place your instrument over here. So the instrument doesn't have to be between the 2 points. Then fixing the level with a tripod stand, approximate leveling by the legs of the tripod stand, and then perfect leveling by the 3 leveling screws. Focusing the eyepiece and the object glass to remove the parallax, and then taking the staff reading. So this is another example of how it's done. So in this case, you have placed your instrument over here and you have leveled it, and your line of sight is horizontal and leveled. This is your benchmark whose reduced level is 100. So first you put a leveling staff over here and another leveling staff at the point whose reduced level you want to find out. Now, one way to do it is to first find out the height of the instrument like we did before. That would be 100 plus 0.973. So that would be the height of the instrument. And then to find out reduced level of this point, you subtract 4.987 from that value to get this reduced level. Other way is by subtracting the difference between these 2 points, 4.987 minus 0.973, and then subtracting the difference from 100, you can directly get the reduced level of this point. Now, like we discussed before, more the reading on the leveling staff, that means that point is lower. And if the value on the leveling staff is lower, that means that point is higher. This would be our backside, and this would be our foresight. So the different types of leveling are simple leveling and differential leveling. In simple leveling, what we do is that we place the instrument exactly midway between the 2 points whose backside and foresight we are going to take. So that process is called as simple leveling. And in differential leveling, we take a number of measurements. The points can be at random distances from the instrument. So here it is. In simple leveling, midway the instrument between the 2 points, and in differential leveling the instrument can be placed anywhere. So this is the difference between simple leveling and differential leveling. So in leveling process, again one more example. This is your benchmark whose reduced level is known, and this is the point whose reduced level you want to find out. If we are doing height of instrument method, that means we will take the reading on the benchmark. The reduced level of the benchmark is known, and you add the reading of the leveling staff in that value, so that becomes your height of the instrument. Then you place the leveling staff on the point whose reduced level you want to find out. Whatever the reading is, you subtract it from the height of the instrument to get reduced level of that point. So the just a quick review of the definitions. Benchmark was a point whose reduced level is known. So in this case, this was the benchmark earlier. And once you have found out this value, so now we have two benchmarks over here. Now, whenever you place your instrument somewhere, the first reading that you take, usually it is taken at a point whose reduced level is known. So that reading is called as backside. When you add backside, in the value of the benchmark, that becomes your height of the instrument. And height of the instrument is basically a reduced level of uh, imaginary plane. So the line of sight, which is intangible, but it's imaginary, intangible thing, and its reduced level is known as height of instrument. Foresight is the reading taken, which is the last reading taken in any setting of the instrument. So in this case, we only took two readings, one backside, and the other reading would be called as a foresight.